Hello dear students, welcome back to our YouTube channel. As you know that we are studying about the paper integral transform, in which we have studied the beta and gamma function in previous lectures, and we have completed with definition, elementary properties, different transformation of beta and gamma function, relation between beta and gamma function, and then we studied about the applications of beta and gamma function. Now, from today we will start our new chapter, that is Laplace transform. Laplace transform. Before going to start Laplace transform, we will try to see some basic definitions which we require to understand what is Laplace transform. So let's start with the definition of piecewise continuity. Piecewise continuity. The definition is simple. We have the continuous function which is continuous but piecewise. So the definition is as follows: a function f of x is said to be piecewise. A function f of x is said to be piecewise continuous. Piecewise continuous in any interval AB. In any interval AB, if it is continuous and has finite left and right hand limits in every subinterval and has finite left and right hand limit in every subinterval. Of AB. Correct. Now let's see the example. We can understand this definition with the help of graph also. Or we can say that, or we can write it as the interval AB infinite subinterval of AB, consider the infinite subinterval of AB, then f of x is continuous in each subinterval subinterval, but the limit point subinterval but discontinuous at each endpoint of subinterval. This quite lengthy definition. We can say that it is somewhat tricky, but if we want to explain with the help of graph, we can easily understand the definition. Here we have the interval AB, in which we have the subinterval A, comma x0, x0, comma x1, x1, comma x2, x2, comma x3, and x3, comma b. Correct? And we have function in interval a x0. The function is continuous, but at the end point of the interval, function is discontinuous, or we can say that the function is continuous piecewise. In this piece it is continuous, in this piece it is again continuous, in x1 x2 piece it is continuous. So it is named as piecewise continuous. Function is continuous but in piecewise form, and it is in continuous in pieces, so it is called piecewise continuous. Now we will see one example for this. Consider function f of x. Consider function f of x is equal to 0, 1, and 0, or let 1, 2, and 3, 0 less than or equals to t less than equal to 1, 1 less than equal to t, less than 2, and 2 less than equal to t, and equals to 3. Let's see this example. Correct? Or we can write interval 2 as, if we draw this equation, then we will get x-axis, y-axis, in which interval 0 to, or we have t here, so we have taken variable t, axis t is equals to 1, t is equals to 2, and t is equals to 3. Correct? From 0 to 1, the value of function is 1, but at the end point we can't include 1 in this function. Then we have the value 2 in the subinterval 1 to 2. So we have have some interval from 2 to 3 and the value is 3, and we have the function f of x is continuous from 0 to t is equals to 1. Again it is continuous as t is equals to 1 to t is equals to 2. Then it is continuous in t is equals to 2 to t is equals to 3. But the function is continuous in piecewise form. So it is called piecewise continuous. We have many, we can take many examples based on piecewise continuity, but it is just for understand what is piecewise continuity. We will stop at this example. In next lecture we will study some more example or more definition which will require for Laplace transform. So keep watching our videos and try to take each example, do each example separately, and by your own you can understand very easily what is given in this lecture. Till then, thank you. Bye.